Oh no.
Hey,
Is it good morning for you, or is it well into the day or evening?
mid-afternoon, 3 o'clock.
Oh, okay.
How about yourself?
Morning time. Just first cup of coffee. West Coast of the United States.
Okay. So early morning for you.
Yeah. I guess it's pretty early. A lot of my meetings start right now. I work with a lot of folks over in Poland and Israel.
Sure, yeah. I know that feeling. We used to start our day catching up with India and then finish the day trying to catch up with West Coast.
Yeah, exactly. Yeah. I remember working late. It's always kind of like a good sign for me to head off to bed if all the folks from India start logging in.
Yeah.
Yeah. And I
In
know
my
I'm really,
current team, I manage
yeah.
people from Israel to West Coast. So,
Oh, okay. Yeah, that's a long day.
yeah.
Hopefully you can break that up.
Yeah, try to. Thankfully, it's just one person on the West Coast, so it's not too bad.
Oh, okay. Hopefully a short meeting.
Hello.
Hey, how's it going?
Hi. Just testing my audio.
It tested correctly.
Good morning.
Morning, Becca.
Hello, everyone.
Simon.
Shall we get started?
Sure. Are we waiting for Joe, or is he not showing up today?
Yes, I had that question, but I guess my limit is 5 minutes past.
Okay.
I mean, I think that's reasonable. So my colleague Balaz is here today, and as discussed 2 weeks ago, he's planning to make a presentation to the group. So unless there's any objections, I guess we should get started.
Hey, Simon, would it be possible for somebody to record?
Yes. In fact, it's already being recorded. Don't.
Is it?
Yeah, it's-
Okay. Oh, yeah. Perfect.
Okay. In that case, I think I'll just go ahead and start. Okay. So hi, everybody. I'm Balazs Nemet from Red Hat, Senior Principal Software Engineer. Been working on DPUs for quite a few years now. I've been aware of OPI, but more from being a fly on the wall than being active. The reason for that is that there was so many things going on, and our team took a different approach than what OPI started off with. We decided that it would make more sense for us to try to get stuff working and then build on top of that before we share what we found to be what we think OPI should be. Okay, so that's a bit of a background from my side. So we have a team of like 4 engineers from our side working on DPUs with different vendors, and we also have, of course, the engineers on the vendor side, and I can talk about that later as well. So OPI, a little bit of level setting. I think it's important to understand why OPI for Red Hat is important, right? So last few years, we have been listening and learning about the details of DPUs. And as I was saying, we've been working with multiple vendors, trying to be a neutral ground, mediating discussions between vendors. I think what makes progress a bit difficult if you put everybody in the same room is that it's almost like having too many cooks in the same kitchen. Everybody wants to drive their agenda. So what we try to do here is we try to be a neutral ground, listen to everybody, and try to come up with something that works for everybody. It's slower to do it in this way, but at least I think we have made some progress, and that's what I would like to share here. What we've been doing is listening and abstracting out and determining how things should fit together. Our goal is to have something that we would like to call OPI certified. As you know, we at Red Hat pushes for OpenShift, that's a Kubernetes distribution, but we want our Kubernetes distribution to support DPUs in an OPI certified way. What that means for us is that we want to avoid re-implementing support for each DPU separately. And then we want to give the customers a promise. Like if they come to our platform, OpenShift, we want them to not be locked into specific vendors, right? So if they start using one vendor DPU today, and they decide that within a few years they want to use a different vendor, they should be able to do so, right? Because some solutions really push customers to have a solution that ties them to the hardware, but we believe that that's not a real flexible position to be in if you're a customer. And we even have customers who mandate a way for them to interact with our platform in a vendor agnostic way because they've had this similar experience in the past where they were tied to specific vendors. And as a byproduct of all of this, if we do a good job, at least this is what we think, then the Kubernetes clusters that we deploy with our DPUs should be able to work with multiple DPUs in the same cluster. It's not a real goal, but if we have the right abstractions in place, I think this is something that becomes like a byproduct of our approach. So it's a way to check that we're doing a good job. Again, it's not the main goal here. The main goal is just to have a way to support all the DPUs. So often we have to have a discussion on what DPUs really are, because depending on who you talk to, their mental model might be different. So I would like to level set for this discussion and hopefully going forward for OPI as well, what DPUs really are. From our perspective, it's essentially a NIC, right? I think we agree it's a PCI card, it's a NIC, but it has a CPU. So that makes it a little bit more powerful and more interesting. I think there is nothing gating by making this statement. But in addition to that, because it has a CPU, it can also run general purpose software. And I'm thinking about the Linux kernel or the Linux networking stack, for example. But in addition to that, it also has accelerators, right? So on the right, you can see there's a CPU, as you know, but it also has these acceleration capabilities. And depending on the vendor, some cards might be better doing some kinds of workloads than others. So based on this view, our high-level approach to getting DPUs enabled in Kubernetes and OpenShift is to first focus on getting the DPU lifecycle management working. And then once we have it fully integrated, not accelerated, but integrated, then we can focus on adding those acceleration capabilities on top. The reason for this is that if you kind of skip the first step, you inevitably have to go back to that, even if you're trying to get accelerations working, right? There's too many moving pieces, and it's hard enough to simply manage these cards. So you will have to go back and add the necessary glue to get the lifecycle management working. So when you think about workloads in general, you can have some workloads that run better on the host and some that run better on the card. For example, if you have some workloads that are running on a host, you'll probably want to use the CPU there, right? Because you're running on the host, what do you have? Probably a powerful Xeon or some AMD flavor CPU there. So you want to leverage those CPUs. Maybe you want to be running there because there's some external things that you want to access that you cannot access from a DPU, right? So for example, if there's a GPU that you cannot access from the DPU, although some DPUs can access GPUs, there might be some devices that can only be accessed from the host side. So that's a reason to run on the host. And then there's another one where you want to provide some kind of abstraction. And then we think about designs that look like Amazon Nitro, where you have tenant workloads running on the host side, and then you don't want them to run on the card because it's like a separate platform, right? So you have your platform be handled by the DPU itself, and then you have the workloads on top. And then, of course, there's also workloads that actually run better on the card. Since the card has, depending again on the vendor that you consider, has particular accelerators. So you might want to run there because you benefit from a performance perspective to leverage those accelerations. Another reason to run on the card is, again, kind of similar to the tenant workloads argument, is that you're able to have a security boundary between the host and the card. So you can run things on the card that the host doesn't even know about. So that's the reason to run on the card. And then finally, of course, if your host is completely bottlenecked because your whole cluster is running at capacity and you want to expand, so you add a card in and you gain additional capacity, maybe not as fast as the host side, but at least you do have the ability to run a little bit more things in your cluster. So from this perspective, you think about workloads, and then you think about them being scheduled either on the host or on the card. So that's kind of the starting point. The problem with DPUs from day one has been that nobody really knows how they should be used. Because if we would know exactly what these cards are going to be used for, we would build those solutions straight away. Like we would focus on those more. But nobody could ever tell us like, okay, we want to use DPUs in this way. So that's why we had to come up with an architecture that allows us to postpone that decision. Like we want an architecture that allows us to tailor to any kind of use case because we don't know the use case yet. So we want something very flexible. So from our perspective, what we needed or still need is a way to seamlessly extend existing cluster workloads to be able to run on the card. So for example, your base case would be, okay, you have a cluster, you have a bunch of pods running on the host, and then some of the pods are doing some kind of network related functionality or something that takes in packets, does something with it, and then forwards the packets out. Well, if you have a use case that looks like this, and you can argue what this pod, this final workload pod is, but if you have a use case that is leveraging a cluster environment like so, then in case you add a DPU inside of your nodes, the idea is to then take one of these pods and then move it down. Okay, so that's one way to look at it, because this allows us to take any existing environments and then have a discussion on, okay, like, can we accelerate it? Can we provide isolation by moving things down? Or what other benefits do we have if we take an existing piece and move it down? Okay. So then again, from a customer point of view, why do they want OPI? Well, they, as a cluster admin, you'll be able to treat the DPUs in the same way, and we can still have some kind of vendor-specific extensions, but we want to make it very clear when the customer is going to use those, and because that means that they might get vendor locked in, right? So anytime we have some kind of API that would require the abstractions that we provide to be broken, then we still want some kind of fallback so that even in those cases, from a functional point of view, they can still move to a different DPUs and still have the same setup. Of course, that means that some of the choices or some of the choices that they are making when they're deploying their setup might be impacted because of the performance differences between specific vendors. But at least from an API point of view, this performance aspects shouldn't be exposed because they are very specific to the particular vendors, right? So what we are trying to do here is we're trying to separate out in our design what is vendor agnostic and what is vendor specific. So you kind of have like this diagram that I'll show you later, where we're trying to push as much as possible into the vendor agnostic part. So we're abstracting out the commonalities, and then whatever we cannot do, we just leave in the vendor specific part. The reason we do it in this way is because then it's easier for us to maintain this, right? Because we only need to maintain the vendor agnostic part once, and everything else, of course, needs to be done multiple times because it's very specific to the vendor. But it's also easier for us to support because we have a very clear boundary between what is open and what is behind the doors of what the vendor is maintaining. Again, we want to avoid the duplication because there's definitely commonalities that we want to abstract out, even though at first it might not seem to be the case. Once we have all of this in place, the hope is then to be able to get faster to market, and we don't want to reinvent the wheel when we get a new DPU or we want to onboard a new DPU. All right, so now comes the actual interesting part, I would say, from the presentation. So what we have been using is 3 levels of APIs. So there's a first level of API. I think this one is the easiest to understand because this is following the boundaries of the systems. So on the right, there's a diagram depicting a system that has a DPU. So on the top, we have the host. On the bottom, we have the DPU. And then we have the dotted lines showing the borders here. There are components running on the host and components on the bottom. So the first API, it's only important to consider this box here, the API 1. It sits between the host and the DPU. So for this to work, you need some kind of communication channel between the host and the DPU. So this is the first, let's say, opinionated choice that we make, that we have a communication channel between the host and the DPU. Based on our collaborations, I think this is the way forward. And the reason is because if you don't do it in this way, you have to manage it externally to your system, and it's very, very cumbersome to do so. So for that reason, we opted to have a direct communication from the host to the DPU. That means that this API, part of it is concerned with setting up a communication channel between the two sides. Once we have this communication channel, then you can consider that this whole bottom piece is actually an opaque box, and you just look at it from the top side from the host side, and then you can ask it to do all kinds of DPU specific things in a vendor agnostic way, right? So you could create a bridge port, you can request it to reboot, you can create a network function. And it's interesting that at this point, if we only allow this API to be the single point where the host interacts with the DPU, then we can also enforce the security boundary at this level of API. Because what we are saying is all these requests are exactly that. They are requests and not like they might be rejected, depending on how much security there is between the host and the DPU, right? So if we're allowing all kinds of configuration to happen from the host, then it just goes down. But if we don't, because we don't trust the host, then we just ignore these requests. And then finally, I already talked about this. So you could envision that this bottom side has this black box. And so there is like this whole this notion of treating the DPU as a complete black box, not maintained by us at all, Red Hat being the vendor neutral party. We just use it similar to any other NIC, except it is capable to do all kinds of interesting operations depending on what the vendor deploys on the card. The next one is a vendor. Oh yeah, so the next one is the second API. This one is between the red and the blue boxes. So we're running on the host and on the card. And you can envision that there is, as I was saying earlier, we try to separate out everything that is vendor agnostic, and then we leave everything that is vendor agnostic specific in a separate box. Between the two, we put an API. We do the same on the bottom side because we envision also being able to run on the bottom side. So compared to the previous slide, API 1, in this case, we're implementing both sides because it allows us to have a more open system. At the same time, we still need specifics to be boxed separately so that all the low-level pieces get grouped here so that when we are working on the vendor agnostic part, we don't need to kind of have all kinds of details of the hardware be implemented here. So even if you consider this level 1 API, this first API, it's already the case that that you need some kind of communication channel. Setting up this communication channel is already tricky. So that's why we need this level 2 API where we can ask the vendor-specific parts to, for example, give us a socket endpoint that we are able to talk to so that whenever we push some request into that socket, it goes down to the other side, right? So this way, we're able to treat even vendors that don't have something that looks like an Ethernet interface that that connects the host to the card. We can even treat it in the same way, right? Because we could ask the vendor-specific part, hey, I need a way to talk to the DPU. Please give me a gRPC endpoint, and it will provide it. And on the backend, it can still translate it down to the card through the driver if need be. It again depends on the vendor because some vendors will just like provide you with a direct IP address, and there will be an interface through which you can connect that is set up by this piece. So it's like it gives us the flexibility to support a wide range of vendors here. Another thing that we want to be able to do in this level 2 API is ask the vendor-specific part, what kind of devices can I manage, right? So there's, of course, because you have a DPU, some kind of devices are present on the host. But again, because we want it to be very abstract and we don't want to make choices that lock us in and prevent us to support other vendors, we make it very abstract in the sense that we just ask this vendor-specific part, please give me a list of devices that I can use on the host side. And of course, there's some kind of plumbing with that as well. So we also need APIs to ask it to do something with those devices. We have a similar API both on the top and the bottom, right? So there's also devices here because it's just another system. So we have also some low-level devices here on the DPU side. But again, we don't control those directly. We always go through this vendor-specific part here. And finally, there's a third level of APIs. So I was talking about having workloads running on the host and then offloading them onto the DPU, just moving them down. But there's still the need to be able to access these low-level accelerators. So think about crypto, maybe there's some other stuff here going on. Well, we don't want the workloads to directly access those because if we do that, then the workloads are tied to that specific vendor. That's why we have to have an additional API layer between the workloads running on the card and those lower-level accelerators. These accelerators can also be used to like program the data plane. You can imagine anything that you would ever want to do on a DPU, you could put into this API and program it through that. The downside of this is that for vendors who are developing this kind of workload, they need to make changes because now they need to start using these new APIs that we're envisioning, right? So this is the downside, but the upside is that they only need to do it once because, of course, if you have different DPUs, they will all work. So these are the 3-level APIs that we've been envisioning and we've been actually working on. So I'll talk about that in a minute. But I first want to talk a little bit about this workload here. So it's a network function. This is what we call a pod that runs on a DPU. So as I was saying earlier, a network function could run on the host, but it's also something that you can offload to the card. So what is an actual network function? Well, it's just like any other workload. It's containerized, but the special aspect of it is that it runs on the card. It has at least 3 interfaces. So this pod that runs on the card, it has 3 interfaces. One for the ingress, so that faces the host, one for the egress, and then there's a control as well. So completely separate from the data plane. So let's say these first 2 are the data plane, and then the control interface is completely separate. And then based on our work, we identified 2 classes of network functions. The first one is a transparent network function, and the second one is more like a gateway network function. What's the real difference here? Well, you can have a network function that works more like a bump in the wire. That means that if the host communicates and the packet goes through the DPU, the host does not know that there is something running on the card that is intercepting the packets. So this is what we call like a transparent network function. And then the other one is more like a gateway. So think about it where like an actual gateway where your packets are routed towards 2. Right? So if you would put a gateway on the DPU, then the packets sent by the host, well, the host needs to know where to send those. So there will be a route pointing directly to that gateway. We're still working on figuring out the details on the network functions, like crystallizing in more detail the different types of network functions. But I think at this point, we came to the conclusion that there's definitely at least 2 classes that we need to consider. The reason is, for example, you can take a few examples to better understand this. If you have something that just counts packets, like a matrix network function, well, if you would be running that on the card, it would just see all the packets and it would count them, but the host would not know that there's something running on the card that's counting the packets. That would be an example of a transparent network function. A gateway-like network function is actually something like that has an IP address that you have to send packets towards to, and then think about something like an F5, Nginx gateway, right? So there's all kinds of proxies that you can run or similar things. That's more on the gateway front. Similar to like firewalls, you could have a transparent firewall that just like intercepts all packets and makes a choice depending on what it sees inside the packet. Or it can be more like a firewall that is similar to a gateway. So your packets go directly to the firewall, then it also routes it and then also does firewalling at the same time. Okay, so my final slide is going back to where I started. So our approach has been to try to actually implement something with multiple vendors. So this is what we've been doing. So you can find the source code here on the GitHub page. It's in OpenShift DPU operator. What this DPU operator does today is that it supports both the Octeon 10 from Marvell and the Intel IPU. And we're using the same API. Since we've been watching what's going on with OPI, we wanted to make it fit as much as possible. So we based our work on top of the EVPN gateway. So within that API, there are a few calls that we took, and then we added more. So we added to those calls some lifecycle management and some network function specific calls that we think should be part of OPI. The reason why we think this is because we've already enabled 2 vendors using the same API, and we believe that the API that we have should work with other vendors as well. So a little bit more about this project. We have a fully automated CI for all the vendors that we support, both Marvell and Intel, and every PR that we push to our repo here goes through a full deployment, full end-to-end deployment, and we have 1 cluster for each vendor. That means that if vendor A pushes a PR, it will be tested both on cluster that has vendor A's DPU, but it will also be tested on vendor's B DPU. The reason for this is because we don't want to have vendor A breaking vendor B's code, right? In addition to that, we have the CI because we want to check that when we have a change, it will behave the same way on all vendors. And it's really extensive regarding testing, so we put everything in code that we support. because it's very easy to try to set up something and make it work and then forget about it. So that's one approach, but there's so many moving pieces, especially during the deployment itself, for example, like getting the DPU up, doing the lifecycle management, the initial bring up is very difficult. So we're also doing the testing on that within our CI. Essentially, everything is in code. And then within this repo, we are currently working on adding the custom resources that allow you to manage the DPUs. Again, everything in a vendor agnostic way. We're doing the reboot controller, which will result in more API calls that we'll be adding later on. And there's also a bunch of bugs still that we're fixing. And then longer term, we're going to upstream the APIs, or we're going to propose to upstream the APIs to OPI, because then I think we're in a very good place to show that the APIs that we came up with will work for both Intel and Marvell, and hopefully for more. All right, so that brings me to the end of the presentation. Any questions?
I don't have any questions, but it looks really great.
Yeah,
Oh,
thanks
sorry,
for
Ted.
the presentation. The first obvious question is why was NVIDIA not in your group of multi-vendors?
Long story. What we did is when we came up with our design, so depending on how much you read into the literature, I think it was said that one of the best designs is the one that can defer decisions as much as possible, right? And due to internal logistics, let's call it that, we couldn't work with NVIDIA early on for this this approach. But what we did do is we had learnings based on what we did with NVIDIA before we started this project. And we made it so that, at least from our perspective, everything that NVIDIA does could fit into the same model. So we did do that, but due to logistics, it was difficult to get them to work with us for this particular project.
And you needed their active cooperation to make it work, so you just stepped back?
Yeah. So everything that you're seeing here has been an active collaboration with at least Marvell and Intel, and then it has been, let's call it, like, based on our experience, we've been guiding the design in a way that should work with NVIDIA as well. But because they weren't in the room, there is of course a risk that we made choices that would gate them, although I don't think that we did so.
Yeah, I would agree. The approach seems to be vendor agnostic, so it should work. Another question, when we look at these pictures where we see workloads on both the host and the DPU, can I think of those workloads as being in the same namespace, the same cluster?
That's a very good question. So again, because we have heard all different kind of perspectives, we support both. So we support a way where everything is in the same cluster, and we also support a way where you define the bottom as a separate cluster from the top. That means that you would have, in terms of Kubernetes, you would have two kube configs, two separate administrators. One can configure the bottom and one can configure the top, or you could have one kube config and have the whole thing be together.
Okay.
It's one of those choices that we try to defer. Yeah.
Yeah. Last question from me, and then I'll open the floor to anyone else who wants to ask. So all of our pictures you've shown here kind of show internal components. How should I think of as the external Kubernetes controller? How does it interact with the workloads as well as these pink and blue pieces?
Right. So there is the DPU operator, and within the DPU operator, we have a daemon, and the daemon further decomposes down into vendor agnostic and vendor specific parts. Of course, because you're interacting with Kubernetes, you are using YAMLs. Okay. So in the end, all these pieces are steered by the user creating YAML files and editing those. I think that's like the answer that you should always get if you think about Kubernetes. But the more interesting part is, as you're getting that information from the user through YAML files, what do you do with those? First, you need to make sure that all the YAML files are not exposing details regarding which particular DPU you are on. So as an example, maybe your DPU requires you to run some kind of agent on the card. Well, we don't expect the user to know this. So the user just says, please set up this node that has a DPU. I'm not even going to say which one, but the only thing I'm going to say is that this host has a DPU. You figure out what kind of DPU it is, what configuration makes sense, and then I go from there. And then the next thing that he can say is that I want to run a workload on a pod, a pod on the DPU. Please create this YAML on the DPU. So it's at that level that we want the users to interact with this. Of course, then if you drill down deeper, let's say, for example, if you're running an Nginx firewall on the Nginx workload on the DPU, you want to be able to configure that Nginx. So then, of course, you need to push in additional configuration into that pod. But that is more of a pod level configuration that we want to do leveraging the normal Kubernetes constructs. I think that is also outside of the scope from OPI. Although OPI does need to provide, what I was saying earlier, a communication channel between the host and the DPU, because that's like the basics. But whatever goes through that communication channel, that's higher level and not necessarily OPI specific.
Yeah, I would agree. If the workload is firewall, then the firewall should have its own CRDs for configuration.
Yeah.
And then app 3 or API 3 would be used by the firewall to maybe push some of those configurations down into the hardware.
Yeah, precisely. Again, in a way that doesn't tie the firewall to that particular hardware.
Right. Yeah. Okay. Well, thank you for answering my question.
Thank you. Anybody else?
This is
So
awesome.
how?
Yes, Paul, go ahead.
Yeah. So as you've started this, since you started this, NVIDIA has released their DPF operator set. How compatible? How uncompatible? You know, how do the two of them compare side by side? Can they be? Are they able to one nested in the other? Are they able to be joined in such a way that they can work together peaceably? How does all of that fit from your point of view?
Okay. So one of the things I talked about early on is that with this API 1, we can always have this whole bottom piece be like a black box, right? So from a host perspective, you would talk through this API, and as long as the bottom API implements, so the bottom piece implements this API, it should be good. So one way to integrate with what NVIDIA has is to make sure that we align on the API from the top to the bottom. That's one way.
Okay.
Another way would be to consider it in a more open fashion, and then it's going to be a matter of figuring out what we need from the hardware. Like there is particular things that we're asking on API 2 from the hardware. And you could think about it as the DPU operator wrapping around the DPF operator to provide a user-friendly API towards the user, right? So it looks up to the user, asks YAMLs, and then behind the scenes, it creates other YAMLs for the DPF operator, right? That's one way another way to think about it. But again, to have that discussion, we need to also bring NVIDIA in.
Okay. And I was under the impression that NVIDIA and Red Hat were working together, but it was a different group at Red Hat that was working together with NVIDIA.
Yep.
Is that?
That's correct.
Okay.
Yeah. So there is work ongoing at Red Hat with NVIDIA for the Bluefield, and they're focusing on the DPF operator, but it's important to realize that the DPF operator doesn't have vendor agnostic pieces. Right. Everything on that front is just let's enable the DPU or the Bluefield 2 or 3 in Kubernetes OpenShift, and that's the end of it. Our approach, actually, you should probably rename the DPU operator to something like the OPI operator, because it's all based around this diagram, meaning that we are really extracting out all the vendor agnostic pieces. And while we're doing this, we're kind of wiggling and shifting things around so that all the vendors are following the same boxes, let's say, in the same diagrams.
Okay.
Okay. So this is Asim. I wanted to ask that these API, are these like work in progress, or these are like documented somewhere?
So we have the API, existing one is the OPI API, Network EVPN Gateway, has already gRPC API for creating a bridge port and all kinds of interesting things. Although we think some of it is very specific to the use case. For example, the EVPN parts of this we didn't use because, again, what we're thinking about is an EVPN would live more in a green box, and they would use the communication channel here, but it's a separate level, right? So we did focus on the plumbing parts of the EVPN gateway that we reused. In addition to that, we have this other additional API. You can look into this one as well. It's as simple as we could make it because we want to not make the wrong choices early on. We have things to initialize everything, and we have ways to query the number of devices because they might be very vendor specific in how they are treated. Then we have ways to create and delete network functions. So we have some level of additional APIs that we are proposing here, but definitely if you look further, doing a reboot where you need to coordinate between the host and the DPU, those APIs will get added here, right? And at some point we'll get to a point that it's stable enough so that we can push that back into OPI.
Right. Thank you.
That's actually an important point here. So on this diagram, if you drill down to the implementation, API 1 and API 2 are gRPC APIs. And then API 3 will probably be something lower level. So think about RTE underscore something at that level, right? So DPDK level or much lower level than the gRPC APIs. The reason for that is because these workloads will tend to see a lot of traffic because they are like intercepting traffic from the host, if you may, and you want them to work at the packet level. So those APIs will be very different than the gRPC APIs that you see here. And the reason why we have gRPC APIs here is because we don't want to necessarily, or try to avoid tying OPI to Kubernetes. So an alternative approach would be, okay, let's just use YAML files and let's use etcd and a kube API server to carry the API messages. But we purposefully don't do that. Instead, what we do is the user specifies YAML files. We convert the YAML files down into a gRPC call, have it be pushed down to the other side, and then convert it back into Kubernetes constructs, because we also run Kubernetes on the bottom, and then program the rest. An additional reason for that is because what we want, again, it's what I've talked about earlier. This could be a black box. It could run Kubernetes, but it could run something else as well. So we want something that is agnostic towards what kind of technology we want, you're going to run on the bottom. Okay, any other questions?
And then from me, I was just wondering about getting some of the links that you're using there. Are you going to be posting these slides to the OPI group, or are they private
Yes.
slides?
I will post them to the OPI Slack channel.
Cool.
And in addition to that, I will also include links to a demo. So we have multiple demos showcasing how this whole solution actually works in OpenShift. The demos are
Cool.
tailored towards Intel IPU. But again, the intent, and you'll see that in the demo, is that the exact same actions can be taken from a user's perspective and have it run on Marvel, for example, as well.
So
Okay.
what do you think your next steps are here with interacting with OPI with the solution?
Yeah. Next steps from our perspective is we first have to complete our implementation on the reboot controller, extend these APIs, and I think then we should have a next iteration of this slide deck, let's say, where we showcase the specific APIs that we have in place, and then we can talk about upstreaming them into OPI itself.
Okay. Well, my personal reaction is this is very exciting. I'm happy to see something that's so aligned with what I think OPI has been trying to achieve for the industry. I think Red Hat's doing excellent work here for everybody. Thank you.
Thank you. If you have questions after the presentation, I'm a part of the Slack channel, so you can just tag me.
So, Sridhar, do we have any more other business today that you know of? There's
Reader
nothing.
says
Paul,
nothing in
do you have
the
anything,
chat.
Paul?
No, I don't have anything else beyond this. Thank you, team. Yeah. So I've been playing with this operator for a while now, and it seems to have promise, and I'm interested to see what the TSC decides as a direction here. I mean, I think we've been given a couple of different options on which way OPI goes with relation to an operator controlling these cards and being the means by which we do management of these cards. So I really would like to get OPI somehow to a place where we make a decision, but I think first we have to get to a point where we have people within OPI who've done enough work with both of these that they can legitimately point out the pros and cons and make a proposal to OPI to move forward with one or the other or both, and how to do that.
Okay. Well, I think you get the last word, Paul, if nobody else has anything to add today. And we should just wrap it up a little bit early, give everybody 10 minutes back.
Sounds very good, and I'll make sure I post this to YouTube as soon as I can do so when it's done being recorded.
Okay. Well, thank you again, Red Hat, for presenting, and thanks everyone for showing up this morning.
Thanks, everyone. Have a nice
Thanks.
day.
Thank you.
Thanks.